Hello class. In this video, I give you an introduction to section 4.3 in your textbook on the law of cosines. In the previous section, section 4.2, you learned about the law of sines, which we use in solving oblique triangles. And remember, an oblique triangle is a triangle that does not contain a 90-degree angle. And the law of sines relates two angles in the oblique triangle and their corresponding two sides via the sine function. So here's an example of a relationship involving the law of sines. It says the sine of angle A divided by side A is equal to sine of angle B divided by side B. Okay? So the law of sines relates two angles and their corresponding sides via the sine function. The law of cosines, right, is also used in oblique triangles, and it relates the three sides of the oblique triangle, side A, side B, and side C, to each of the corresponding angles inside the oblique triangle. So there are three equations relating to three sides, and one equation for relating to each angle inside the oblique triangle. So this first equation relates the three sides to the angle A. We have side A squared is equal to side B squared plus side C squared minus 2 times B times C times the cosine of angle A. And we have a similar equation relating the three sides to angle B, and relating the third equation relating the three sides to angle C. And then we have the fourth equation that the sum of the three angles has to add up to 180 degrees. So given the three sides of an oblique triangle, we can use the law of cosines to figure out what angle A is, what angle B is, and what angle C is. And also, given two sides of an oblique triangle and the angle between the two sides, we can use the law of cosines to figure out the length of the missing side and the size of the two missing angles. And so we're going to demonstrate that with examples in this exercise. And the first example that we're going to look at, we're given two sides of the oblique triangle and the angle between the two sides. So we're given side B is equal to 1 unit, side C is 3 units long, and angle A is 80 degrees. So that's kind of this situation with this triangle over here, this oblique triangle over here. We're given angle A and the length of the two sides that angle A is between. So I'll draw a 80-degree angle. That's angle A. And side B we're given is 1 unit. And we're given side C is 3 units long. We have to determine what angle B, angle C, and side A are. So I can connect the end of side C with the end of side B, okay? And you see now we have an oblique triangle. This is side A over here. This is angle B up here, and this is angle C right there. And so using the law of cosines, we can figure out the missing quantities. So let me scroll my screen up so I have more space. And using the first equation in the rectangle up above, we can figure out the length of side A here. We have A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of angle A. So we just plug in for side B, side C, and angle A, and solve for A squared. So we have B squared is 1 squared, C squared is 3 squared, then 2 times B times C is 2 times 1 times 3, and then we multiply that by the cosine of 80 degrees. Now when we simplify the right-hand side, we got to follow the order of operations, PEMDAS. And so we got to do the exponentiation, and then we can do the multiplication, and then the addition and the subtraction. Well, 1 squared is 1, 3 squared is 9, and 2 times 1 times 3 is 6. Now, when you do this multiplication, right, in your calculator, right, you can just type in 2 times 1 times 3 times the cosine of 80 degrees and hit enter. I'm going to write out the value of cosine 80 degrees to emphasize that that is a numerical value. And the numerical value of cosine 80 degrees is 0.1736 to 4 decimal places. So make sure your calculator is in degree mode when you punch in cosine 80. Otherwise, if you have it in radian mode, you'll get the wrong answer. Well, 1 plus 9 is 10, and 6 times cosine 80 degrees is minus 1.0419. And so when we do that subtraction, we get a squared is equal to 8.9581. And then when we take the square root of both sides, we get a is equal to 2.9930 to 4 decimal places. Now, I'm writing my answers out to 4 decimal places because I want to minimize round off error. We got to include the value of a squared in finding angle B or angle C, and the value of A as well. And I want to minimize round off error in calculating those values. So the length of this side of the oblique triangle, right, is 2.9930 units. Now we can use the second equation in the rectangle up above to find angle B, or the third equation to find angle C. Well, I use the second equation to find angle B. And the second equation is B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of angle B. Let me draw a line here so we keep our work on the left separated from the work on the right. Now angle B is what is unknown, okay? So we can plug in, there's 2 approaches to this. We can plug in for side A, side B, and side C, and then isolate cosine angle B, or we can solve this equation for cosine B and then plug in for little a, little b, and little c. There are 2 approaches to this. In my next video, I actually solve for cosine A or cosine B or cosine C. So I'm just going to plug in this equation. So when we plug in for little a, little b, and little c, we have 1 squared is equal to a squared. Well, a squared we know is 8.9581. C squared is 3 squared. And then we have minus 2 times a, which we learned already is 2.9930. Then we multiply that by c, which is 3. And then we multiply that by the cosine of angle B. So you gotta be really careful, okay, when you're using numbers, to 4 decimal places. It's easy to get lost in the math, okay? And now again, we gotta follow order of operations in solving for cosine B. 1 squared on the left is equal to 1. 3 squared is 9. And now we can do the multiplication. 2 times 2.9930 times 3 is equal to 17.9581. And that's being multiplied by cosine angle B. Well, the 8.9581 plus 19, they're like terms, right? So you can add those two together, and we get 17.9581 minus 17.9581 times the cosine of angle B. Now at this stage, you might be tempted to say 17.9581 minus itself is equal to 0. And so this is equal to 0 times cosine B. And that'd be wrong. Because order of operations says you got to do multiplication before subtraction. And this 17.9581 is being multiplied by cosine B. So you can't subtract these two numbers from each other. Okay? Some students will do that, and that's incorrect. You got to multiply this number by cosine B and then subtract it from this number. Well, we can subtract, right, 17.9581 from both sides, right? This number here, we can subtract from both sides. And on the left, we'll have 1 minus 17.9581, which is equal to a minus 16.9581. And then that's equal to minus 17.9581 times the cosine of angle B. And now to isolate cosine B on the right, we have to divide both sides by this factor, minus 17.9581. And when I switch the two sides of the equation, I have the cosine of angle B on the left is equal to minus 16.9581 over minus 17.9581. And we have the cosine, when I do that division on the right, we have the cosine of angle B is equal to, actually I'm going to write it up here. We don't need this stuff up here anymore, but I will save this part down here, A. We have the cosine of angle B is equal to, on the right hand side, 0.9443. So the cosine of this angle B here is equal to 0.9443. Well, I can take the inverse cosine of both sides, and I get angle B is equal to the inverse cosine of 0.9443. Now, because this is a positive number between 0 and 1, I know that angle B is going to be an acute angle. It's an angle between 0 and 90 degrees. If this was a negative number, the inverse cosine of a negative number between minus 1 and 0 will give you an obtuse angle between 90 and 180 degrees. So using your calculator, make sure it's in degree mode, take the inverse cosine of 0.9443, and we get angle B is equal to 19.2 degrees. So using the law of cosines, we were then able to figure out what angle B was here. Okay? Now, to find angle C, okay, we don't have to use the law of cosines, right? We can just use the fourth equation in the rectangle on the previous page. A plus B plus angle C is equal to 180 degrees. So when I plug in 80 degrees for A, 19.2 for B, C is the unknown. We put side A up here. A is equal to 2.9930. from that result up there. And now when I solve for angle C, I get angle C is equal to 80.8 degrees. So using the law of cosines, given this, we're given two sides and the angle between the two sides. Okay? We're able to use the law of cosines to figure out the length of side A, and the law of cosines to figure out the size of angle B, and then using A plus B plus C equals 180, we were able to figure out what angle C was. Okay? Now, I forgot to give this type of problem a name. Your textbook, because we're given a side, an angle, and a side, we're given two sides and an angle between the two sides. Your textbook calls this a side, angle, side problem. Okay? So whenever you're given two sides of an oblique triangle and the angle between the two sides, it's called side, angle, side problem. You have to use the law of cosines to solve that problem. Okay? To solve for the unknown side and the unknown angles. Okay? Now it is possible sometimes to switch after you find the length of the missing side. Sometimes it's possible to switch to the law of sines to find the missing angles, but you got to be very careful because if one of the missing angles is an obtuse angle, the law of sines will not give you an obtuse angle. You will have the largest angle that the inverse sine function will give you is an acute angle of 90 degrees. So sometimes it is possible to switch to the law of sines, but once you start off with the law of cosines, it's usually best just to stay with the law of cosines in solving the problem. Okay?